So, good morning, everybody. It's 9:30 sharp, so let's get started with the Radext meeting. If you don't want to be at Radext, go elsewhere. So let's, as usual, start with a note. Well, if you managed to get to a IETF Wednesday without seeing it, congrats, but your days are counted. Here it is. So the agenda for today is actually not very packed. I was a bit enthusiastic after the last meeting in Berlin, where huge amounts of people showed up, great discussions. So I reserved 90 minutes to have a bit more time. Turns out that we actually only have 60 minutes full of speaking time. So if you have lots to discuss, take your time. We're going to have it. As usual, let's start with the usual volunteer thing. So we would need a JavaScribe. Anybody willing to JavaScribe? Yeah, okay, thank you. And we also need a minute taker. And if you want to have an easier job and people actually helping you doing the minutes, you could use Etherpad, and we could all do minutes. But I need one designated person anyway. Yeah, remote participants are usually not the best in minute taking. Okay, guys, I'm the only chair here today, so I don't have a chance of taking minutes myself, so it really has to be somebody. Okay, so Ryan is taking minutes, thank you. Okay, so the rest of the agenda is that I will give a short overview about our documents as they are now, document status overview. As you will see from that overview, it's a bit special this time because pretty much most/almost all of our documents which we have on the charter are pretty much done. So we don't have anybody talking about active working group drafts this time. So instead, we will have plenty of new things to talk about. And I think that's actually a great opportunity to think again about what Radext should be doing in the future. So there's an influx of work, and I find that pretty well. So there's going to be a 10-minute presentation about radius extensions for MUD, held by Brian. Then we have DHCP packet signing via 802.1x, just a short presentation of 5 minutes. You might be wondering, hey, what is this doing here? So Alan is actually presenting this in SARC, and he is aiming for an AD sponsorship. But this is something we should, well, we might want to be aware of, even though there is no radius in the title. Then we have LoRaWAN authentication in radius. This is the second presentation on that topic. Last one was very well received and very vivid discussions around it, so that's going to be nice, I hope. And lastly, there is a not quite ready work about proxy considerations, how to do proxying right and how not. Again, held by Alan de Kock remotely. But there is no ID to read about that yet, so we will all be surprised. And finally, 5 minutes for the wrap-up and next steps. And actually, well, we should have 30 minutes of leeway at that point, so everybody gets to the next meeting. But again, if you feel you have to discuss something, please do go ahead. So speaking about our document status, so we didn't manage to publish an RFC just yet since last IETF, but we do have one document in the RFC editor queue, and that's the radius extensions for IP port configuration and reporting. It's in a legendary revision number 17, meanwhile. To be honest, I thought we need lots of agenda time this time to talk about this one because it sailed into a perfect storm when the IESG evaluated it. But as it turned out, all of the issues were solved by the mailing list, and the document was allowed to go on. The status I have on the slide is actually from yesterday, when the document still had a missing reference, which was data types, but the IETF is moving fast. So data types has actually, meanwhile, proceeded to the RFC editor queue. So both of these documents are going out anytime now, as soon as the editor is done editing. In that context, the other document we have, data types in radius, is still set out here as IESG approved, but a couple of hours ago, it went to the RFC editor queue. So these were 2 working group items, which we don't have to do anything about anymore, so it can be considered done here. And that pretty much empties our charter, except for 2 documents, one of which we also have pretty much done in terms of working group stage.
Sorry, just a note on the Jabber, on Jabber. So Alan Decock says the data type was just accepted for publication by the IESG, and a new revision will be published after the IP port document has done its IANA updates. So that the data type document includes data type for the IP port attributes.
Yep. Yeah, okay, so data types is going to have its fair share of IANA actions because it's creating a huge long list of attributes in the registry, but I guess not a big deal for IANA anyway. So the last 2 documents we actually have on our agenda is the dynamic authorization proxying. We had a working group last call just after the IETF 96 meeting, and nobody spoke up, so I take that as a good sign. And this means, by process, working group last call completed without comments means we can move forward with publication. So we still have to assign a document shepherd and do the document write-up. Turns out that Lionel Moron isn't here today, so well, that was a mistake, so we have a new shepherd here. No, just kidding. So Lionel and me will sort it out who is shepherding this document, but it's on its way, basically, and there's nothing more to be done. And the last document we have is then my own document on considerations on how to use EAP response identity right. I still didn't manage to submit an update, so I just have a few words on it on the wrap-up slide, and that's basically all. It is the only document that is actually still in the works in this working group in terms of our charter. So then we have these proposals for new work. So Jim Sharp volunteered to do the reduce TLS BIS document at some point. So if you don't have an update, you don't have to say anything, you know.
Yeah, I ran out of time in the last thing. I expect to have an ID ready for Alan to look at within a month, so this should be up before the end of the year.
Mm-hmm. Okay, and yeah, this would be a document which is very definitely inside our charter, so I think this is clearly new work coming up. We also have the LoRaWAN authentication radius. The author submitted an O2 version just before the cutoff, and we'll discuss about this today. We had a good reception already, so let's see how it goes. Another document that is circling around since a while now is the radius extensions for network-assisted multipath TCP. There is meanwhile an O3 version, and the authors requested a call for adoption, so I don't think there's any problem with that. So as soon as IETF is over, I will start a 2-week call for adoption. Please do read the latest revision first, and then form your opinion. Do you think that's something we should be working on in Radext or not? And last, well, maybe and least, I don't know, is the extended packet header for radius. There was a presentation last time and an initial draft. To be honest, I didn't hear any updates from the authors. They also got a fair amount of beating in the last meeting, so I don't know what their plans are for this one. Unless I hear from them, I think we can drop this off the radar, unless they say otherwise. Right, that's it for the document update. So let's now think about the individual draft discussion. And the first one up would be Brian for the radius extensions for MUD. And in a few seconds, you'll have your slides.
Good morning. This is so this work is in conjunction with some work that's happening in the Ops area working group. And you can go to the next slide, please. So I think everybody understands for the events of the last few weeks, there's no longer any doubt that IoT devices are under attack. And we knew that already before, but this is some work we've been doing for some time to try to address this. We understand that not only the device is under attack, but so are the networks the devices are attached to, and that's really the focus that we've come from. how can we better increase the security of the network from these things that are just, it's hopeless to assume that they're secure or ever will be secure. So next slide, please. So what our goal is to be able to protect the network from the things and protect the things from the network. I'm sorry to keep looking up here, but I can't see otherwise. So from a network security perspective, I think we'd all understand that the best place to protect against something connected to your network is at the network edge, where the port that this is connected to. And that's what we'd like to do. We also understand that most of these things aren't going to be authenticating themselves with 802.1x, although there's some provision for that. But practically speaking, many of them won't. We also understand that there'll be a lot of different types of IoT things showing up, and it's really going to be impractical to assume that on your AAA server that you're going to know about them ahead of time. You're going to assign some sort of policy to them. You'll certainly never really know what kind of network access these things need, and you'd really like to be able to restrict that network access to what it is they just need, as to try and reduce the threat profile of these things. So in fact, most of the time they have very simple needs, which is they need to talk to a DHCP server, get an address, and then they've got some manager somewhere in the enterprise or in the cloud that they have to actually talk to, for example, maybe they're relaying sensor data up to it, or maybe they're getting data back down from it. But what you really like is to just have these things be allowed on your network to do just that. Just get DHCP, for example, and just talk to who it's supposed to talk to. But how on earth are we going to know that, given the previous statements I made? So the goal is with this thing called manufacturer usage descriptions, where a manufacturer can describe usage of what this device needs. And you can go to the next slide, please. So the main draft is this ops area working group draft. And very simply, what the way that MUD is intended to work is that their manufacturer, when he produces a device, he does a couple of things. He creates basically a file on a web page in a particular format that describes, if you will, what we're really interested in. What he's going to describe is some information about network access policy that's necessary. And then when he manufactures the devices, he includes a URI in one of the discovery protocols that this thing is going to send out, which is basically a hint telling the network, hey, if you want to know more about me, go resolve this URI, and it'll tell you some interesting things. So this draft defines the format for the file, defines different ways that the URI can be propagated by the device, which could be through DHCP option or LLDP, TLV, and then additionally it could also come in an X59 certificate. There's a certificate extension that's been defined, but for the purposes of this discussion, that's not as interesting as the other two. So once that URI gets to the network, then the network can forward that to the Radext server, and he can work with an associated device called the MUD controller, which simply is going to resolve the URI and discover what's in it, create ACLs, and then send it down to the access port on the network, on the network edge. So what we've discovered when we were going through implementing this is, well, if this is coming from DHCP or LLDP, access port can pick this thing up, but he really doesn't have a way to get this to the Radext server. So we needed a new attribute in Radext to send that off to the Radext server. And that's really all this draft is doing after all that explanation, but it's a missing piece of the puzzle. Okay, next slide, please. So this is just sort of pictorially what I was just mentioning. You can see at the top that the thing is advertising the MUD URI. The network edge needs to forward that over Radext to the AAA server, which is working with this MUD controller sort of role to resolve this MUD file, MUD URI, to get the file back, create the ACLs, and send them back down. And the only thing missing is what's in red. So that's what this draft does. Next slide, please. In fact, that's most of the draft, I guess, is describing attribute that's necessary. Alan had commented against the -00 that we should be using the data types draft, so we'll be doing that in the next version instead of putting the ASCII art in, but we still would need the same thing in the end. Okay, next slide. There's a little bit of context in the draft around what I just described verbally, and then there's some security considerations in there about, well, so should you really accept this URI that's coming across maybe unsecured, or if and another and then the next step that might be, as Alan pointed out in his comments, that maybe the Radext server should be a little worried about when he's getting a URI from the from this Radext attribute that maybe didn't come in an authenticated fashion. So the answer to these things is generally yes. If the URI comes unprotected, you really shouldn't completely protect it. But there is some. So there's two answers, two sort of points here. One point is it's definitely helping devices that are not lying, in that they are protecting themselves, and there's value in that. And then the question is, well, how do we protect against devices that are lying? And really the answer is you need some correlating information, some device profiling, or some other kind of events that you're actually looking at the traffic from this thing and deciding if he's really acting as that kind of device or not. And this, I think, it's a little bit of a fuzzy answer, but that's pretty much where we are. The best possible approach really would be to send the URI in the certificate, in which case we don't need this Radext option. But in that case, it's going already to the AAA server. It's actually, as part of authentication, certificate authentication validation, he's going to actually discover the URI, and then he can get the resolve that and get the policy from there. But as I said, we understand most devices aren't going to act like that, at least to start with. I think that might be my last slide. Yeah, so this is just a request for comments. We're not ready to ask for anything beyond that at this point. As the MUD draft proceeds, we may ask, we probably would like to ask for this to be a working group item, but I think we should wait a little bit on that. So any comments?
So a comment on Jabber from Alan. Vendors have historically had a hard time keeping web servers up, for example, for firmware updates.
I'm sorry, could you say that again?
Yeah, so vendors have historically had hard time keeping web servers up or keeping domains registered. So there is a large chance that the URI is non-existent or malicious.
So a URI that is non-existent is certainly possible. That is to say, maybe the manufacturer goes out of business. Right. So if it's not there, you're no worse than you were before you didn't have a URI. I would say that. Second of all, there's certainly strategies where URI can be put on a third-party server or something like that. Actually, in practical circumstances, I would expect the MUD controller sort of operation probably to cache it after he gets it the first time, so he always has it available. So that would help at least a particular enterprise that has seen one of these before, but it wouldn't, of course, help other people that have never seen it before. But as I say, if they can't resolve it, well, they're no worse off than they were before. In terms of malicious URIs, really you just need to, as I was saying before, I'm not sure I have a better answer than you need to do some additional device profiling and evaluation of the traffic of this thing using maybe some IDS or something. Additionally, of course, you can put things on, so you can put IoT devices, in particular the VLANs, and there's other sorts of separation techniques that could also, you must also do along with the ACL, right? There's no restriction here on what you would normally do with your policy. It's just we're trying to give the network a hint of, hey, this is the kind of device it is, and here's a hint about what kind of access it needs. And then certainly the Radext server can apply any kind of policy it wants as he would normally. We're just trying to automate the ability for him to know what this is and what it needs to do. I don't know, Alan, if that answered your question or not.
Yeah, so personally, to the pitch in, so Alexander Pelov on this, I agree, and maybe, of course, this is not a problem of this draft, but mostly of the MUD draft that's going to be there. It is because IoT devices will tend to live much longer, potentially without firmware updates than what we are seeing today. So this could be, it could be interesting to see how the MUD draft advances in the other working group. On a personal note, I find this work very interesting. So I think that this is something that I'd like to see in the radius. And then on Jabber, going back to Alan, he's expressing his opinion that parsing JSON is hard. Lots of buffer overflows in JSON parsers and timeouts on non-existent URIs can affect radius servers. So just like a general remark that parsing the mud file can potentially be of some danger. And
Sorry, was that the mud file or the mud URI?
So parsing JSON is hard.
Okay.
So he's referring something to, I'm not sure which
Okay.
part. And then two more comments. So Alan agrees that you are pretty much answered his question, and he also thinks it's interesting and useful as work.
All right, thank you for those comments. Okay, thank you very much.
So, yeah, just a second. Yeah, I also have a couple of questions, all as an individual. To be honest, as an individual, I'm very sympathetic to the mud work. I'm just trying to wrap my head around here. So what you have on the network edge here is what we would usually call the NAS, and the device they're just trying to authenticate would be the IoT thing. But you know, in this draft, basically the NAS also is the authenticating device by proxy.
Well, actually, we didn't mean to say that. So the NAS should be just forwarding. I mean, in a standard environment with the Radius server, he should be just forwarding the URI off to the Radius server to decide. Essentially, it's an informative thing, right? The Radius server can decide to ignore it, or he can decide to use it, as I was describing earlier. So certainly, you know, the bottom line there showing from the AAA server to the network edge or to the NAS, there's absolutely no change there whatsoever. In fact, in our implementation, you know, it was all existing attributes. You know, Radius attributes is just, of course, because you're trying to do the same thing you would do for any other device at that point. We're trying to enable the ability to decide what those attributes should be.
Yeah, that's exactly my point. So every other device can trigger the authentication itself because it wants to authenticate.
Oh, okay.
So the NAS here has to decide, is this an IoT device connecting to me? And do I have to take this authentication by proxy role for it? And then my question is, there is only this DHCP option. And if this is there, the NAS will act on it and do stuff and consider the device being an IoT device. But if that's correct, maybe there's some interesting attack coming up itself. Let's imagine Windows PCs get a very popular virus, and they just have to send a DHCP option with the target they want to DOS, and all of a sudden, everybody will try to get a huge file from that web server, and the web server goes down.
Okay. I guess the answer is yes. I mean, but that's no different than probably a lot of other situations. Though, in any case, yeah, one must be careful with, right.
Yeah, okay, that's all.
Okay, thank you. And please, if you have more comments, send them on the list. We'll be producing a -01 in a bit of time with resolving some of these comments.
Okay, thank you, Brian. Then the next one up is DHCP packet signing via 802.1x. And please give me a few seconds to get Skype and the slides up and running. So, Alan, do you want to call me with video, without video? Anytime, do it now. Because we didn't pre-announce that we need remote participation possibilities, and so, okay. So if audio is enough, I'm told that you can just push the button and get in the queue. Yeah. Yeah. Alan? any of them would work, but neither of them does. Wait a second. Louder, maybe?
Sure.
Yeah, here we go.
All right. So if you put up the slides, this is work which came out of the security area, where there was some discussion about DHCP v6 and various DHCP security options. And I pointed out that DHCP v4 was entirely insecure, and that perhaps we might want to leverage 802.1x. So if you go to the next slide, yeah, there's no ties between 802.1x and DHCP. So you have this wonderful, super secure TLS-enabled method to get on the network. You prove who you are, you prove that you know who the network is, and as soon as you're on the network, you send this DHCP packet, and hopefully someone somewhere who might be the correct DHCP server answers. The point from Ted Lemon and various other DHCP people was that the switch mostly blocks all the bad DHCP traffic. So you're pretty sure that you're talking to the real DHCP server, but it never hurts to have cryptographic signing, in my opinion. So if you go to the next slide. So the idea is basically take a page from EAP. You have the 802.1x MSK, you have various derivation methods for it. So like TTLS, there's, this string TTLS signing key or something, and you just do something similar for DHCP. The nice thing is that both ends can derive the same key without communicating with each other or without exchanging things. And then you just start signing packets, and you gain some additional level of security by having actual secure DHCP. So next slide. Sorry, still there? I think we did that. Next slide. How does it work? You sign the keys. Yes, exchanging the keys. So this is the 802.1x server, more typically the Radext server, needs to exchange the keys with the DHCP server. And this is where the phrase, insert magic here applies. There's no API at all between Radext and DHCP. There's no shared database. There's nothing. These keys tend to be fairly secure. You probably don't want to put them in a database because they're used to sign packets and other people can get at your database. So that's sort of implementation defined and open to discussion. Next slide. So what does it mean when you sign the DHCP packets? It means that the servers can talk to each other, that they're run by people who talk to each other. Anything else? And this is one of the questions that Ted Lemon brought up. Does it mean that it's a trusted DHCP server? Well, no, because this is a new thing we're adding with new meaning. All you can say at the minimum is that the two servers have talked to each other and exchanged data. Next slide. So problems, yeah, there's a lot of details not worked out. It's sort of a stab in the dark at this point. DHCP doesn't provide for capability negotiation, so there's no way for either end to say that they can do this other than they just start signing packets. 802.1x doesn't provide for this kind of capability negotiation, so there's no real way in any of the existing EAP conversations to say, hey, I can do this DHCP thing. You might shoehorn it into the inner tunnel in TTLS, because that allows you to exchange any radius attributes, essentially, but it's not generic and it's not really good for any other EAP attributes. So there's really no way for either end to signal that this is happening. So next slide. So the questions, is it a good idea? Does it help security? Does it not hurt security? Can it be implemented, and will people implement it? I know for me, taking a look at it, I can cheat a little bit here because I can write a radius/DHCP server that caches the keys in memory, and it's, you know, maybe 1,000 lines of code and a couple of flags and a configuration file somewhere. Other people who have other implementations will find this rather substantially more difficult. So the question is it useful? Will people do anything with it? This is more of a discussion for SAG, where security area work, where I expect people to hammer me quite negatively, but it's worth a conversation. And I think that's it. Questions?
Yes, Alexander Pavlov here on the mic. Just a short question, Alan. Do you have any idea how the key exchanges will happen between the AAA and the DHCP server? So who is going to initiate any initial thoughts on how these keys will be requested by the DHCP server or pushed by the Radius server?
The simplest thing, I think, from implementation point of view, is for the Radius server to tell the DHCP server that it has keys available, and either it can push the keys via some pre-configured secure channel, but otherwise the DHCP server has to ask the Radius server every time. Now, the DHCP signing in RFC 3118 allows for a secret identity. So it doesn't just sign the package, it says which secret it's signed with. So that's one of the questions. You could reserve a number there and say, this is the Radius thing. But there does have to be some way for these two systems to communicate, or the Radius server could put a key into a database and the DHCP server could look it up.
Okay, thanks. I find this question really interesting, but when we need to discuss this, maybe on the mailing list or other one. Yeah.
Okay, so I would have a question myself. Maybe I'm just a bit slow in terms of which keys are used where. So is this only for EAP methods and you use the TLS master session key basically? Or? Alan?
Sorry, sorry.
Yeah.
It would have to be only for EAP. Only those EAP methods which derive a master session key. So SIM, TLS, TTLS, EPKA, all that kind of stuff, not MD5.
Okay, just one follow-up then. That is the key material only available to the AAA server and the supplicant then, not the one which is sent in the MS MPPE keys usually.
Yes,
yeah.
Those are separate keys. So if you look at the draft, it has references to TLS and to the TTLS thing. So those MPPE keys are derived by taking the server random from TLS and the client random and a fixed string, and then doing a PRF hash over that. And that's defined for every EAP method. And so the idea would be to do something similar and say, well, you have these MSKs and you go one way to derive the MS and PPE keys, and you go another way to derive the DHCP signing keys.
Brian Wise, Cisco. Say, Alan, I think this is interesting. I do some work in the IEEE 802.1 group on 802.1x, so I've had some kind of questions about how we would actually extract the keying material. And actually, I'm not sure if anybody does that today. I'm just wondering, I mean, it's an interesting idea if it could even be a more of a general concept for 802.1x ability to extract keying material for different purposes, such as TLS, I think, has that approach today. But we certainly don't have that in the standard. I'm not sure how you would do that without changing the standard. Do you have any thoughts on that?
I don't think this requires any changes to 802.1x. It's just once you have that MSK derived from the EAP session, you derive an additional key, a sub-key from that. So I don't think it requires any changes other than implementation changes on the Radius server, the DHCP, the supplicant, the DHCP client, and the DHCP server. And all these systems now have to talk to each other and exchange information. But from the point of view of 802.1x, the packets look exactly the same. And the only thing that changes in DHCP is suddenly the client packets are signed, and then the server responses are also signed.
I'm wondering, I was just thinking about that TLS key extraction method. Do you assume the use of eTLS when you have the MSK? And could you actually use that facility to extract that in terms of getting keying material?
Yeah, I think so. So my initial look through the various EAT methods show that this seemed to be possible. The hope is you don't have to come up with derivations which is specific to each EAT method, but that might be required, in which case you have to issue sort of a jumbo draft that would patch all of the existing EAT methods, which I'd prefer not to do.
Sure. Okay, thank you.
Yes, a note on Jabber by Jim. Sorry? Okay, yeah, so I will not read it. But I would say that it's interesting. I would like to pitch in that it would be worth thinking about a more generalized idea of having this, especially for IoT devices, where you would like to limit the number of key exchanges over the air. So you could use the Radius server to actually push lots of keys to many different servers. So in this case here we have the DHCP and the access point, for example. But it can be some other servers, and if there is like a generic way of which this could be achieved, like pushing the keys to different entities that are not co-located, then that would be a nice thing to have.
Yeah, so that's interesting in terms of, I read Jim's comment on Jabber too. My only concern with deriving a DHCP signing key from the MSK that gets sent to the AP is the MS and PPE keys are visible to everyone in the Radius infrastructure. And that's sort of bad for key security. On the other hand, it does mean that these DHCP signing keys are now independent of the EAT method, and you don't have to patch on the existing EAT methods. So this is something which I think deserves longer discussion in the security area, and lots of flames and arrows from people there.
Okay, so this is Stefan again as a personal comment. I will certainly be in those security area discussions. The thing for me is in a roaming consortium like we have in EduRoam, it may very well be that the AAA server that has the key is on the other side of the planet compared to the DHCP server, which hands out the IP address. So in any case of a roaming scenario, I think this has no chance of flying high. If, on the other hand, the MSMTPE keys are being used, maybe it's not perfectly secure, but at least it has a chance of surviving because it happens in the same administrative domain, because the access point is in that same domain as the DHCP server. So definitely worth thinking about.
Yes, that's a very good point. I'll have to update the draft accordingly. I think that's it for me, Dan.
Okay, thank you. Okay, that was a good discussion. Let's continue in the same spirit with the LoRaWAN authentication in Radius.
Hi. Hello, everyone. I'm Arun. I'm going to present the updates and the current status on the LoRaWAN Radius draft. So since we have a couple of buffer time, I would take the opportunity to have a quick refresher of what is this draft about. So next slide. So this is more about the authenticating the device, which is really constrained in resources. So we have a LP1 architecture here, which consists of an end device, which is really constrained, and the manufacturer and a network server. So in the manufacturer, he provides certain amount of identifiers and the root key to the end device. And also to the network server, he provisioned the same kind of keys and IDs. So when the device wants to connect to the network, he sends a join request to the network server, and the network server verifies the identities and derives a session key, and he sends the join accept, which is encrypted. So here, next slide. So these are the two main messages which are exchanged between the end device and the network server. So the join request has the identifiers plus the random numbers which is generated by the end device, whereas the join response or join accept has the application random number which is generated from the network server. So the rest of the entities are more specifically related to the radio part of the technology. Next slide. So what this draft is about to introduce a AAA server into the existing authentication procedure in order to push the standardized protocol. So what we're going to do is to delegate the functionality of authentication from the network server to the Radius server. So we're going to have the same kind of messages across the radio. What we are going to do is to introduce new Radius attributes, such as join request and join accept, which are transferred using the Radius protocol to the Radius server. So the Radius server does the job of authenticating and returns the success or failure message to the Radius server, to the network server. The network server in turn forwards the message to the end device. So these are the few Radius attributes which we would like to introduce through this draft. Next slide. So the current status of this draft, there are a few modifications in the introduction part in the section 1, which insists or which emphasizes the importance of the AAA server in this scenario. And we added a reference to RFC 6158 Radius design guidelines, which specifies the data structures outside, which are defined outside the Radius. And in the LP1, they had the first working group session in Seoul. IETF 97. Though in the current charter, they don't have any specification on the radius infrastructure. There are quite a bit of interest from other private or other individual persons, and also in one of their architecture draft, they have mentioned or they have included AAA as a part of the architecture. So what our plan is to keep updating the draft with the inputs from LP1 group plus the individuals, and wait for the next charter to be included. And also, since we use the radius protocol for transport, we would like to get the inputs from the Radext group as well, and check if it can be useful and adopted as a working group document. Yep. Next slide. Yep.
Okay, so
Okay, that's it.
you have this one slide about acknowledgements, and that's it. Okay. Then
Mohit, so if I understood, there is never a reject. There is just join request and join accept. There is no join reject.
Yeah, there is no join reject as of now, but if there is a failure, you don't get any message in the network server.
So I wonder what would it do to the radius, like on the client and the server side, on what kind of state machine handling, and like how does it affect my implementation, my current radius client and server implementation? If there is like, if for some reason the AAA server sees that this device cannot be authenticated or something is wrong, then what should it send to the network server? And like,
yeah, that's open for discussion actually. Right now, we have a current implementation in Go, so we don't actually we have a failure in this step, on the third step, and so we failed to generate the network session key and other session keys. Maybe we can include a radius reject or access reject in this.
and like my second question is more fundamental. Why do we need new attributes? Why can't we just put like in the access request, access accept payload? Like maybe I'm missing something, but like what's so special that needs to be done here, which cannot already be done by putting like things in the payload? I mean, this is the join request is a request, and you put it as a payload in the access request, and then whatever things you get back, or maybe if you put additional things in the access accept, maybe then you need new. My question being is are there things that cannot be done by existing messages and attributes that for which you need these new attributes?
The idea is to have multiple attributes to transfer the complete messages which are in the LoRaWAN, and also the session keys in different attributes.
So maybe a question from me then. Radius always needs attributes to send data from A to B as part of the payload. So if you think there is an attribute which can convey all this data here, please let us know. But I'm not aware of generically sending a byte stream in any way. So personally, I think that attributes are needed. That's fine for me as an individual. In any case, you will have to have the access reject on the red part of the conversation in your spec, because there's nothing Radius hates more than not getting a reply. Because this simply means maybe the radio server is actually dead and I have to ask a different server and have to fail over. And the ambiguity of non-response is either a reject or non-response.
I remember in our implementation we send the access reject actually.
Yeah, so that part is important. If you can do without a negative acknowledgement on the green side of things, that's entirely your thing, I think. Yeah, so there is this part in the blue one where the manufacturer sends enrollment data to the radio server.
Yeah.
How does that
At
actually
this
work?
moment, it's burned during the manufacturing period, or we can also use certain management protocols to distribute the keys, the root keys.
Okay, that's a bit interesting. I don't let anybody talk to my radio server as a radio server administrator. The radio server does its thing, and that's it. So I thought this blue arrow would be like I buy the device and I get a scratch card with some kind
Yeah, I
of
mean,
ID
it's
and-
like pre-configured on the device, and you can also manually configure on the radius.
Okay, so I type
mean,
it in.
or to the device, you can use management protocols to send the
Okay.
keys.
Yeah, if I send them to my radio server, that's fine. If some manufacturer would be allowed to send something to my radio server, I would be, you know.
So I would like to ask like a general Alexander Pelf, a general question to the group and to the room is if there is any interest at some point to what would be the chances of getting this document as part of as a working group item. So of course we'll be publishing this as individual submission for as long as there is interest, but it's how is there any interest here, and yeah, how do you feel about it?
Yeah, if you ask me up front about how your chances are, then it's a bit difficult. But yeah, this is something that is doing radios for authentication things, and that's what we designed radios for. So it's certainly not out of the line. And I think it has chances, yeah. But in the end, if you want to have it as a working group item, you have to call for adoption. And enough people have to say, yeah, that's a good thing to do. And whether that happens or not is really a question of the future.
Okay, thank you.
Right, then we have the last discussion, which is then the proxy considerations document, the non-document. So let me get that back.
All right. So if we go to the next slide, this comes out of some discussions with Jim Shad about proxying in UDP versus TCP, some discussions we had in Berlin. So UDP is required to retransmit, so proxies clients are required to retransmit as per RFC 5080 section 2.2, because TCP is reliable, TCP client don't retransmit. And what happens with proxies then? So if we go to the next slide, there should be a very simple diagram. So let's say there's a NAS which sends data to a proxy via UDP. So the NAS clearly has to retransmit. The proxy then sends things to another proxy via TCP. Clearly this does not retransmit. And then the proxy 2 sends radius to the home server via UDP. And what does proxy 2 do now? Presumably retransmit, but none of the documents make that clear. So if we go to the next slide. So worse. RFC 5080 is almost a decade old and very, very few NASs implement it. So RFC 5080 has exponential backoff for retransmissions, and most NASs just do a fixed counter. You know, we send 5 packets at 3-second intervals and then give up. Also, is the UDP retransmission behavior optimal? And what I mean by that is Bernard at least was very clear that for UDP chains of proxies, each UDP proxy must not retransmit unless told to do so by a retransmission from the NAS, because this has end-to-end behavior. That might work for routers, it's not clear that it's the right thing to do for radius, especially once you have failover and all those kinds of stuff, especially in a complex environment like eduroam. So all these proxy issues are not adequately covered by the existing RFCs. So if we go to the next slide. So what we know is the radius servers are relatively smart and can be upgraded easily. The NASs are dumb and they're hard to upgrade for very good reasons. I'm loath to upgrade my switches weekly. There's no radius routing protocol. So ideally, you don't need to discover that the upstream server's down by doing retransmits. You get told by your routing protocol, except we don't have one. So all the signaling has to be real-time in band. And then the question is, what needs to be done there and how do you do it? So next slide. So I think it would be useful to have a best current practices document covering proxy considerations, but we also need consensus on what it recommends. I think some things are relatively straightforward, like in the design or the diagram earlier, you know, if a proxy is receiving packets over TCP and forwarding them over UDP, then the proxy is responsible for retransmits on the UDP side. But none of the documents say that. And then the harder issues are UDP proxy chains. What do? I think most current implementations just retransmit whenever the upstream retransmits. But there's not a lot of consensus as to why this is a good thing. And I think especially once you get into things like eduroam, correct me if I'm wrong, Stefan, but most of eduroam is all TLS anyways. So next slide. And discussion. Do people have opinions on this other than Bernard, who I suspect is not in the room?
I can confirm Bernard is not in the room.
Okay.
So before we start with the discussion, maybe I have to correct you because you are wrong. Turns out that we have TLS in many countries, but that's like 15 to 20. And eduroam is now in 70 countries worldwide. So unfortunately, the typical admin, even on the country level, finds it easier to provision a UDP shared secret once and have eduroam for the next 20 years running, rather than updating a certificate every year or so. So we are not quite at the point where we say everything is TLS. There's unfortunately plenty of UDP around.
So this perhaps makes it even more important to define what the UDP retransmission behaviors are and why those are good ideas. Because right now, my recollection is that I think going back to 2865, it might be that old, or maybe a bit later, I was having discussions with Bernard about this, trying to figure out which things, you know, which retransmission behavior was best. And Bernard was very, very insistent that doing what I'd call synchronous retransmissions would be best, where the proxy only retransmits when signaled to do so by the client. He's very strong in that opinion, but I don't know whether that's better than having the proxy decide to do the retransmit or why. I don't know that we have the data to define why one is better than the other.
So Jim is coming up.
Jim Schott. One, I don't think the fact that eduroam administrators are using PSKs is necessarily going to stop us from being able to switch over to TCP, because you can do PSK even with TLS. So you don't have to do certificates unless you want to do long jumps, which they may still actually find to be, especially the country ones, may find to be very useful, that they can stop having to support lots of things going through them. But I think this document is vital for us to do. It's probably really important just for the pure UDP case. We absolutely have to have this for the UDP TCP case, because we actually have no idea what's supposed to happen there, and everything we currently think is probably wrong.
Yeah, I can only echo that. In Jerome, we've been doing this for more than a decade now, but it's pretty much like, yeah, it works, sort of, and that's it. But nobody really has any good answers so far. If we can find them, that's great. Question is, do we find an answer that actually fixes all kinds of proxy problems, or is the best thing we can do is document them? But it has to be, somebody has to think about it and has to put it in writing. Yeah. Okay, nobody else have the mic, so I guess that's it. Goodbye, Alan. Okay, so that was it for the individual draft discussions. If one of the authors of these documents says, okay, I've got a draft, I want this adopted as a working group item, please contact the chairs or just talk on the mailing list, and we run call for adoptions of those. I think there's plenty of interesting stuff here that Radext could be working on. But actually, that's it for today then. So all I can do is have a wrap up here. There is this footnote about, hey, Stefan wanted to talk about this EAP identity response draft. So I didn't find the time to update that one. I think what we took away from the previous discussions is that the basic premise that this draft is starting from, namely that you could be in a situation where you have to have multiple identities to choose from, and you don't know which one to choose, is that everybody said, well, it shouldn't be like that. You should always have exactly one choice how to authenticate to one given network. That I agree with. That would be nice. It's been the world so far. But especially if you take a look at the Wi-Fi Alliance passpoint things, there is a sequence of events that where this gone wrong is certainly possible. So it might be that you do end up in this situation. The reason being that a network is not necessarily one network. So you can have an access point with one SSID advertising that you can connect to it with a multitude of identities. And if you're particularly unlucky and you have identities with more than one provider, which are all compatible with this access point, you do have that choice. So I will rephrase the document to point in the direction that you only have to read this if things have gone really wrong, and you've got to get it right at some point. But that's basically it. So I certainly hope to have an update before the next IETF. And then that's it from this document. So anybody having any working group related comments? Open mic. Okay, then I guess we are adjourned. Thank you for coming. And if you didn't sign the blue sheets yet, there is one here, and another one should be as well. So identity begins, what one of the assets I got. Take a look at the identity begins, it is the last bytes of the next 256 bytes people request identity. That's not one. Later on we have 10,000 different values. And if I were to tell you you can log in with those credentials, I would have to see the stream of 10,000 values. And you don't have this as they have this concept of consortium.
But then you can reduce the 10,000 to 10 or 5.
comprehension is that Nexus can say you can log in with everyone to the consortium identifier, but also with iPads, and also with identity mobile. And you have three constants now. They're all being served by one. So you have one network, so you use any of the three entities. And you come here, you have extra information, you have like have a T-mobile one, you can like this one. And then you have the Wi-Fi line basically that you expect your service providers has two of these for you.
That's fine.
Because every service provider sends access.
So at some point, where you have choice, then it's for all.
It's usually the case. If you have configured the routers, if I see this is a new
It's not the market. That and